Okay, so good morning, online students. Am I audible to all of you? It would be better, online students, if you switch on your cameras, some of you, so that session. Okay, so from today we are beginning science and technology classes. Some of you would be starting your classes with science and technology. Some of you would be like the merged batch. So science and technology, why do you think is there in your syllabus? Have you given a thought to it? क्यों रखा है यूपीएससी ने सिलेबस में? Is it okay if I talk in Hindi in between? No? Okay. Okay, science and technology, if you see what are the important themes, let's first see the themes, then we can discuss the significance of this particular topic. Acha, before we begin, let me give you my introduction. So my name is Jwala Kumar. I was born and brought up in Jamshedpur, which is Jharkhand, Tata Steel. So it is a steel city. Then I have done my engineering from IIT Roorkee, and I got campus placed in SAIL, Steel Authority of India. I worked there for 5 years, and then एक कीड़ा काटता है civil services की तैयारी करने का, just like you. I have given 3 interviews in civil services. I couldn't make it to the final list. I got selected in BPSC, Bihar Public Services Commission, but I did not join because I have a passion for teaching and I do some other stuff also. So that is my small journey. The reason for guiding you all is that we often make common mistakes. So I have made many mistakes in UPSC preparation itself. So I feel that those mistakes, if one can avoid, then your journey can become shorter and it could be enriching also. So during the course of the class, I would share that what are the common pitfalls which all of us make. So I have been teaching from past 6-7 years, and I'm seeing every year, or most of the aspirants would be committing very similar type of mistake. Coming to science and technology portion, so there is a perception that this is a small subject. It would be true also to a certain extent from mains perspective. But if you look at from prelims perspective, you might have seen prelims paper this year. देखा है prelims का paper? तो prelims में कितने सवाल हैं साइंस एंड टेक के? अच्छा, जो मेजर सब्जेक्ट्स हैं हिस्ट्री, इसके कितने रफली सवाल हैं? Out of 100 questions, roughly, can you give me some ballpark number कि हिस्ट्री के कितने सवाल होंगे, ज्योग्राफी, पॉलिटी, इकोनॉमिक्स, जो कोर सब्जेक्ट्स है? सो यू हैव टू बी गुड एट दीज कोर सब्जेक्ट्स. दैट इज यू. सो कैन यू गिव मी नंबर्स ऑफ क्वेश्चंस दैट यू कुड सी फॉर हिस्ट्री? 20 प्लस. चलो 15 to 20 मार्क्स. व्हाट अबाउट पॉलिटी? हाँ, इस साल का पेपर देख करके पॉलिटी के बारे में नहीं बोला जा सकता. इस साल बहुत कम सवाल थे, बट जनरली वी कैन से इट वुड बी इन द रेंज 15 or more than that also. Roughly we'll say 15 questions. Geography again 15 to 20 questions, and economics again 15 to 20 questions. I am not very accurate in this part. This is just an average number for past 10 years. And if you look at science and technology, how many questions on an average we are seeing? Definitely we are saying 15 questions, and sometimes it is a little more also. And if you analyze the past 5-10 years paper, तो यूपीएससी ने अपने गैजेट नोटिफिकेशन में कहीं पे भी ये नहीं बोला है कि साइंस एंड टेक्नोलॉजी से वो 15 सवाल पूछेंगे प्रीलिम्स में, बट इन रियलिटी दे आर आस्किंग 15 क्वेश्चंस. एंड कैन यू सी द वेटेज ऑफ साइंस एंड टेक्नोलॉजी इज नो लेस देन द बिगर सब्जेक्ट्स दैट यू थिंक. So one of the reasons that why most students would not pass prelims would be not focusing on some of the smaller subjects like science and technology and environment. For a competitive exam like UPSC, you cannot ignore any part. Every question matters. You know the marking scheme. So those who are new, just to give you an awareness. So one question that you get right will fetch you 2 marks. But one question which you have attempted and you got it wrong, how much marks have you potentially lost? -0.67. तो वो जो गलत कर दिया आपने उसका है, बट आपको 2 मिलने भी तो थे. So you are actually losing for one. So you have filled a bubble. Just in terms of practical terms, you filled a bubble. That is, you marked an answer and you got it wrong. So you lost 2 marks because it went wrong, and you were penalized also. So you are losing 2.6 7 marks for one wrong bubble. So you should realize that in prelims, one wrong bubble can be a big blunder for yourself. And you will see that blunder more prominent in CSAT and in GS paper, especially in science and tech portion. So what is the perception of science and technology? That if I read my current affairs, if I just cover newspaper and magazines, my science and technology will be covered. But you will see the question paper and you will analyze that mostly it is conceptual in nature, and there would be then factual aspects added to it. So you should have some conceptual clarity with respect to science and technology also. It's worth investing time in science and technology. In fact, from my personal experience, I would say the best input output ratio that you will get of all the subjects would be of science and technology. So here you will have to put a lot of effort, but to get high accuracy, you would require much more effort. But here with less effort also, you can score quite well. So this is the area where you should not ignore. So my only argument here is that you should not ignore small subjects like science and technology, especially for prelims, because every marks will count. So this is the practical importance of science and technology for you. So those who are planning to give your prelims, you should understand this part. Yes, in mains, we can accept the fact that its weightage is less. So in mains, the total marks of all GS paper is 1750, 1000 marks for your GS, and 500 marks for your optional, and 250 for your essay. Out of that, you could see 50 at max or 50 to 60 marks of science and technology. So here the percentage weightage in mains is hardly 3%. So in mains, it is about 3%. But in prelims, you can see the weightage is about 15%. So in order to clear your prelims, you definitely have to be good at science and tech. In mains also, it's not only in the GS paper 3 that it has importance, but sometimes essays are technology based also. And in ethics also, there would be technology related questions also. So if you have a good understanding, broader understanding of this subject, you can fare quite well overall in the paper also. So let's begin with what are the important themes. My voice is too slow. Can you check? Voice come aa rahi hai. So what are important themes in science and technology? Let's first list it down and then we'll see how we'll cover them. See, the classes would be very conventional in the sense that we would try to understand concepts. I will explain you the concepts and then I'll dictate so that you can write also. Some things which we will not be able to cover, I'll provide you notes for that part. But most of the things we'll try to cover in the class itself. So going by conventional method only. So there are important themes which has been mentioned in your GS paper 3. So space, science and technology. Then nuclear science and technology. Energy technology, this term is not mentioned in your syllabus, but UPSC has been asking questions on this topic both in prelims and mains. That is why this topic has become very, very important. Then we can look at defense technology. Smaller topics like nanotechnology, IPR, intellectual property rights. Then we can look at IT and computers. And one big part or big chunk is your biology and biotechnology. So the keyword in your syllabus is actually biotechnology, but to understand biotechnology, you need to know some basics of biology. So this itself will be a big portion. This we'll cover sometime later. So we will begin with space first. So these are some themes which have been given in your syllabus, in your GS paper 3 syllabus. And you should have clarity with respect to these particular themes. For example, when you're reading newspaper, anything that you have come across in newspaper regarding these themes or these topics? आजकल क्या चल रहा है न्यूज़ में? ट्रेड रिलेशंस वो तो यहाँ पे वो आईआर वाला टॉपिक हो गया। आई एम आस्किंग इन टर्म्स ऑफ साइंस एंड टेक्नोलॉजी, क्या चल रहा है, कुछ न्यूज़ में चल रहा है? हाँ, ईरान का न्यूक्लियर वाला जो न्यूज़ में है। सो व्हाट इज द की वर्ड दैट यू कॉट फ्रॉम द यूएस ईरान वॉर, दैट व्हाट यूएसए डज नॉट वांट ईरान टू डू? They do not want that Iran should be able to develop nuclear weapons. They are trying to stop Iran from doing what? Nuclear enrichment. So this is a concept that you should be understanding. तो कितना enriched fuel है उनके पास, कितने percentage enriched fuel है? Have you come across this? No. So Iran is having 60% enriched uranium. Now, what is the significance of 60%? With 60%, can they make a nuclear bomb or not? That is a question. 85%, 90%. तो क्या आपको enrichment as a concept पता होना चाहिए? So it is part of your syllabus itself that you should understand this topic. You should understand in general what do you mean by enrichment. If you are having nuclear power plants, you need fuel. You need enriched uranium. To build nuclear bombs also you need enriched uranium or plutonium. How much enrichment level is required? What is the process of enrichment? That is basic knowledge that you should already be knowing. So if you're seeing it in newspaper, it should not surprise you, because you should have already covered in your basic coverage of the syllabus itself. So enrichment you should understand. So it's not only about enrichment, but you should understand how does a nuclear power plant work. How many nuclear power plants does India have? Some factual aspects. What is India's 3-stage nuclear program? So have you heard this, that India has sufficient thorium but does not have sufficient uranium? So India wants to utilize thorium, but thorium has an issue. We cannot directly utilize. So this is part of your syllabus itself. So if you know all that story, then enrichment will not boggle you actually. So you should be knowing this from the entirety perspective. Getting it? और कोई न्यूज़ में good that AMC? So fighter, so 5th generation of fighter jet. So in defense technology, he is mentioning about AMCA. या उसके पहले न्यूज़ में था S-400. All of you came across S-400 during the Indo-Pakistan brief conflict. So we have purchased S-400 from Russia. Aware about this? सुना है, न्यूज़पेपर में पढ़ा है? नहीं? तो आपको ये पता, अभी आपने सुना होगा कि Israel has been using Iron Dome to protect itself from incoming threats from Gaza Strip. No? तो आयरन डोम क्या है, S-400 क्या है, why India purchased S-400 and not Iron Dome? And this was a mains question actually. S-400 has been asked 4 or 5 years ago in UPSC. So it is in news now, but it has been in news from past 7, 8 years itself. So you should know what is an air defense system. So it is part of an air defense system. So it is part of your syllabus. So you should know this. So anything which is coming in current actually would have a context. If you know the basic story and the basic premise of it, you can understand current also quite well. Anything in space that you are seeing in news nowadays? Yeah. Yeah, so we are planning for Chandrayaan 4. So Chandrayaan, as you mentioned, we are planning for Chandrayaan 4. How many Chandrayaans we have sent till now? We have sent till now 3. What is the significance of 2 and 3? Chandrayaan 2 and 3. 2 में क्या हुआ था ऐसा कि जो न्यूज़ में रहा था? Chandrayaan 2, if you remember, we had failed to soft land on moon. Chandrayaan 3, we became the 4th country to soft land on moon. तो आपको ये कॉन्सेप्ट पता होना चाहिए पहला कि सॉफ्ट लैंडिंग क्या होता है, इतना क्यों डिफिकल्ट है कि बाकी देश नहीं कर पा रहे हैं, and the ranking becomes important. So you should understand this idea of soft landing itself. So here Chandrayaan, in Chandrayaan we are not sending humans as of now, but you are aware that humans have already been sent to moon, Neil Armstrong and Buzz Aldrin. So if we are not able to soft land machines, do you think if we fail to soft land when we are sending Indians on moon, would that be a good news? No. So this is a technology that you should be knowing. You should be having some idea. Now what UPSC has asked, on this, or in this particular theme, you can see that ISRO sends unmanned mission, but is not able to send manned mission. What are obstacles in manned mission? That is the theme of the question. तो आपको पहले बेसिक डिफरेंस बिटवीन व्हाट इज अ नॉर्मल मिशन, अनमैन्ड मिशन और मैन्ड मिशन क्या होता है वो पता होना चाहिए. मैन्ड मिशन के चैलेंजेस क्या होंगे वो पता होना चाहिए. उसके एडवांटेजेस क्या होंगे वो पता होना चाहिए. सो इफ यू हैव कवर्ड द टॉपिक in a comprehensive manner, then Chandrayaan 4 would just be a news for you, that this is the next step which ISRO is taking for moon mission. You would have come across Subhanshu Shukla name also. Subhanshu Shukla coming out with books, and he went to space. He became the second Indian to be in space. So that whole mission becomes important. Or Gaganyaan mission, he is part of the Gaganyaan mission. He has been selected as one of the possible crew members of Gaganyaan mission. So Gaganyaan mission will be what? A human mission of India for the first time. So NASA had sent humans way back in 1969 itself, 1970s. So you can imagine it has been more than 5-6 decades that India is trying now. So we are lagging behind with respect to some missions. So you should know why we have been lagging. What is ISRO doing about it? So that type of question is the core of UPSC preparation. Then UPSC will also ask from you कि चांद पे जाने का फायदा क्या है जब यहाँ देश में इतनी गरीबी है. So the topic is technology and society, or technology, how it is bringing socio-economic development. So you should be prepared to answer that type of question. That would be true for every technology that we are developing. They will ask that how is ISRO contributing in agriculture sector? How will biotechnology help in agriculture sector? How will nanotechnology help in agriculture sector? So how will energy technology help in agriculture sector? How can nuclear also help in agriculture sector? तो ये क्या हो गया कि आप कुछ भी इन्वेस्टमेंट कर रहे हो, R&D कर रहे हो, उसका कोई फायदा, प्रैक्टिकल फायदा तो निकलना चाहिए ना फॉर सोसाइटी. सो दैट थीम वुड ऑलवेज बी रेलेवेंट फॉर UPSC. So when we prepare our science and technology portion, we would try to address these parts also, that how could we tackle questions like this, that what is contribution of ISRO in socio-economic development of our country. And you will see these are questions which have been asked, but you should have been prepared holistically. Then only you can address these type of questions. न्यूक्लियर में इंडिया में क्या न्यूज़ में आया था बहुत रिसेंट पास्ट में जो आपने पढ़ा हो? Anything that you came across in news? Yeah. Yes. So good that you are aware about this. Prototype fast breeder reactor. The keyword here is breeder. तो न्यूज़ में आपने पढ़ लिया ब्रीडर, तो आपको ब्रीडर के बारे में पहले से ही सारा नॉलेज होना चाहिए. And it's not new. Dr. Homi J. Bhabha conceptualized India's nuclear program way back in 1950s. And his vision was that India would have to rely on breeder technology. तो आप ब्रीडर पहली बार देख रहे हो, पर इंडिया के लिए नया नहीं है, ये आपके लिए नया हो सकता है. तो आपके बेसिक कोर्स में ये होना चाहिए कि हाँ ब्रीडर क्या होता है, ब्रीडर रिएक्टर का एडवांटेजेस क्या है, चैलेंजेस क्या है, वेयर आर वी इन ब्रीडर टेक्नोलॉजी. सो दोज एस्पेक्ट्स you should be knowing. If you know that this was the news that a few years ago, last year, PM went to visit PFBR. He saw or witnessed core loading. Core loading मतलब जब फ्यूल को लगाते हैं रिएक्टर में उसको core loading बोलते हैं. He witnessed that, and this year in April 2026 it achieved criticality. अब ये एक दूसरा कीवर्ड आप सुनोगे तो आप इससे भी परेशान होगे कि ये क्या आ गया. But this is also a concept. So if you already know this concept from beforehand, when you see it in the newspaper, it would not trouble you. So that is why we say that when you're doing your foundation, build your basics well. If your basics are very strong, then newspaper would also appear very easy to you, because you will understand all the terms and keywords there and the context also. Okay. Anything else that you have come across in news nowadays? AI आजकल बहुत न्यूज़ में, ChatGPT or Claude, these are in news. Now, what do you think can be the area of question making of UPSC in AI? क्या पूछ सकते हैं आपसे? AI and copyright issues आ रहे हैं. तो ये इशू आया है कि AI जो कंटेंट जनरेट कर रहा है, AI is creating content and the content that is created by AI, can AI have copyright over the content it has created? Do you think that is a debate? Do you need to know this debate? इसका मतलब आपको AI और copyright भी जानना पड़ेगा. So we will see that copyright comes in IPR. So you have to understand copyright first. So copyright के regime क्या है? Copyright Act क्या है? Copyright में exceptions क्या है? आपको पहले वो पता होना चाहिए, तभी जाके आप AI and copyright को interlink कर पाओगे. So you need to know basics, then you can go for interlinkages also. And do you think AI is also raising ethical questions? You would be aware about the fight between some AI companies and US government in recent US-Iran war. हाँ, क्यों ये लड़ाई चल रही थी कंपनीज और गवर्नमेंट के बीच में, यूएस गवर्नमेंट के बीच में? So US government was asking these AI companies that they should provide AI services to find out the targets in Iran. So AI-based targeting system they wanted, but some companies denied. Let's say the owner of the cloud denied. So AI can be misused also for killing people. So those ethical questions arise when we go for new advancements in technology. तो ethics भी आ जाता है. जैसे ही technology आएगी वहाँ पे ethics भी आएगा. In fact, when you come to biotechnology, a lot of ethical questions will come. For example, in biotechnology, have you heard this term? This was in news in recent past. 3-parent baby. In UK, 8 children have been born by this route, 3-parent baby. Aware about this 3-parent baby situation? Acha, we will discuss. Did you come across CAR T cell therapy for cancer? CRISPR-based technologies. So CRISPR, so as you mentioned, CRISPR. So CRISPR is a gene editing technology which is becoming very, very popular nowadays. So CRISPR को use करके क्या हम diseases को treat कर सकते हैं? Yes, we can. But क्या सारे diseases को treat करना चाहिए? That is also the question. So we'll try to see those aspects also, the ethical aspects of these things also. So when we have biotechnology, we can change humanity, we can change genes, we can change genomes. So everything could be changed with biotechnology. It is so powerful technology. So it raises the question, should we be doing that? कैपेसिटी तो है, पर क्या करना चाहिए? क्या एवोल्यूशन को चेंज करना चाहिए? क्या नेचर को चेंज करना चाहिए? आप जीएम क्रॉप्स के बारे में सुनते रहे होगे, जैसे बीटी कॉटन का नाम आपने सुना होगा, और आपने अभी रिसेंटली धारा मस्टर्ड हाइब्रिड मस्टर्ड का भी सुना होगा. सो मस्टर्ड, there are issues. There are people who are opposing legalization of mustard. Why they are opposing? So that context you should understand. Okay, so this is just to give you an idea that what are the different themes for science and technology portion. So we'll be covering these topics class after class. So let's first begin with space. Now space, science and technology, there is no fixed syllabus for this part, but based on the questions they have been asking and the depth of the questions they have been asking, we can see that what topics are important for this particular part. So when you see space, तो ऐसा नहीं है कि वो सिर्फ टेक्नोलॉजी पूछेंगे आपसे कि पीएसएलवी में कौन सा फ्यूल यूज हो रहा है, या जीएसएलवी क्या है, सेमी क्रायोजेनिक इंजन क्या है. आपसे बहुत बेसिक साइंस भी पूछते हैं वो. बेसिक साइंस, दैट इज व्हाट इज अ सेफिड. आपने अभी नहीं सुना होगा, यू विल कम अक्रॉस सेफिड्स. सो दीज आर यंग स्टार्स. सो आवर सन वाज बोर्न, and similarly other stars are also born. So you should know about star birth. If you know about star birth, you will come to know about what are young stars also, such as Cephids. So basic science bhi poochte hain. They will ask you a very simple question: does light travel always in straight line? So UPSC has asked these questions. Do you think light always travels in straight line? Can light bend? Do you think can gravity bend light? That type of understanding. So they have asked even questions like Einstein's theory. So again, basic science also they have asked. Einstein's theory of relativity. Suna Einstein's theory of relativity? We will. So for those who are coming from science background, you would be aware, but you might have forgotten. And those who are coming from commerce background, I will try to simplify it so that you can understand it. How many of you are from arts and commerce background? Okay, a major chunk. And from science, obviously the rest of you. सो साइंस वाले बच्चों को लगता है कि साइंस एंड टेक्नोलॉजी तो क्या है, ये तो हो ही जाएगा, बट ये हो नहीं पाता है एक्चुअली में. सो इन यूपीएससी एंड कॉमर्स स्टूडेंट्स दे वुड थिंक, commerce and arts student, they would think it is not my cup of tea. But you should invest time here and you will see that the return would be better for you. What are some basic things that we'll be covering? We can begin from uh, this particular theory, that is Big Bang theory, that is origin of universe. Then we can look at composition of universe, origin of universe, composition of universe, what is real matter, what is dark matter, what is dark energy. These terms you should be familiar with. Then we can look at our galaxy, which is the Milky Way galaxy. I'm listing down the important keywords and topics that we have to cover. Some understanding of the Milky Way galaxy we need to have. Then we can look at our solar system. This is more important. Solar system, first we would look at the structure part, that how it is structured. Then we'll look at sun. So sun is our star, so we will try to understand how any star is born, birth, its activities. We will come across terms like solar cycles, solar maximum, solar minimum. So what do we mean by solar max, solar minimum? That we'll try to understand. And our sun, like any star, will also die. So its death also we'll try to look. Then we can look at what are planets, asteroids. Is the board visible to all of you? Acha, you have. This screen is not working? Okay. Asteroids, meteors, and comets. Okay, so I've got a request that some students are from South India, they can't understand Hindi. Okay, so that is all okay from my side. Dictation part I'll definitely do in English only, don't worry. Then I'll not write here. Then we can look at other basic concepts like what do you mean by Earth orbits? So Earth orbits, what do you mean by low Earth orbit, medium Earth orbit? I'm writing the short forms now. Geosynchronous, geostationary. Is the font okay to all of you? Is it legible? Font legible from the back? Then what do you mean by polar orbit? What do you mean by sun synchronous orbit? I'm just listing down the topics. So you don't need to worry if you cannot expand it now. These are just acronyms for now. Sun synchronous orbit, transfer orbits, and another important idea or concept here is Lagrange points. Then we can look at some technology aspects. So in technology, we'll try to understand what are engines. We'll try to understand what do you mean by cryogenic engine. What do you mean by cryogenic? What do you mean by semi-cryogenic? Those type of questions. Then we can look at launch vehicles of India. Launch vehicles such as PSLV, GSLV, SSLV, next generation launch vehicle, NGLV, RLV, TD, and we can compare it with Falcon. What about Falcon Heavy? किसका है Falcon? Yeah, SpaceX. So we can have a comparison also. Then we can look at space missions. In space missions, we'll try to understand unmanned missions and manned missions. And in manned mission, also a follow-up would be space stations. We'll see a few of the names and missions itself. Then we can also discuss the concept beyond solar system. So here, theory of relativity. यहीं पे कुछ कॉन्सेप्ट्स हैं जो इम्पोर्टेंट है आपको पता होना चाहिए. दैट इज आइडिया ऑफ स्पेस टाइम. What do you mean by space time? What do you mean by black holes? Singularity in some more detail. What do you mean by event horizon? So these concepts were mostly given by Einstein. Then what are gravitational waves? We'll try to simplify it for you, don't worry. So these are some complex theories, but we just have to understand basics. And wormholes. Done? Acha, online students. Artificial intelligence, nuclear enrichment, and Australia's uranium agreement, how to control fake content. Yes. Done with the board? Okay. So let's begin with the Big Bang theory itself. Yeah, still writing? Okay. This is just a map for you to know that what are important topics that you should be knowing in space itself. And you will see a lot of questions have been asked from these themes. Have you heard about Big Bang theory? Okay, can anyone tell me what is Big Bang theory? It is explosion and universe is? Okay, acha, so the universe is expanding. So how can we know that it is expanding? There is a redshift effect, and because we see that universe is expanding, we can take, or when we go back in time, we can definitely say that everything would be coming from then a पॉइंट ऑब्जेक्ट. जैसे बॉम्ब के एक्सप्लोजन में क्या होता है, हर चीज़ बिखर जाती है, आप उसको रिवर्स ऑर्डर में जाओ या रिवर्स टाइम, इफ यू गो बैक इन टाइम, सो यू विल सी दैट एवरीथिंग वुड बी कमिंग फ्रॉम अ सिंगुलर पॉइंट. दैट इज द आइडिया ऑफ Big Bang theory. Can you tell me other aspects about this Big Bang theory? When did it happen? 13.7, 13.8 billion years ago. See, what is Big Bang theory in general? You should have an idea. Big Bang theory is one of the theories to explain about origin of universe. We don't know about origin of universe. So when you don't know anything about anything, then what do we do? Scientists क्या करते हैं फिर? Scientists, they would give theories and hypotheses. It is one of the hypotheses, one of the most acceptable hypothesis that has been given. So we accept the Big Bang theory to a very large extent. And Indian mythology also has some hypothesis, no? That how this universe came into existence. We can discuss that. But let's first see Big Bang. So the idea is, as you friends mentioned, that universe is expanding. If you reverse it, it means that everything would have come from a singular object. That singularity was a point object which had nearly infinite mass and infinite density, and it was very, very hot. So 13.8 billion years ago, when you say ago, means you are referencing it from present. So we are saying that 13.8 billion years ago it started expanding, and because of the expansion it led to creation of space. It did not only lead to creation of space, it also led to creation of matter. But it not only led to creation of matter, it also led to creation of time itself. Okay, so we'll try to understand this part. So this theory says that everything originated from something called as singularity, and this singularity started expanding very rapidly, and we see that the universe is constantly expanding. So let's say this is the present, so this is now, and this point would be, you would say, 13.8 billion years ago from here. What should I write t here as? What do you think should I be writing t here as? T क्या लिखना चाहिए? There was no concept of time itself. तो अच्छा Indian mythology पढ़ा है. There was nothing existing, and there was existence and non-existence at the same time. Yes, so we would say time was zero, or time also began with Big Bang only. So with Big Bang, space came into existence and time also started for our universe. And then initially there was rapid expansion, and then there was cooling. And because of cooling, matters started forming. So when you see hydrogen, what is hydrogen? It is just combination of proton and electron. So hydrogen is when an electron starts to revolve around a proton, that is hydrogen. So the first element formed after Big Bang was hydrogen. That is, with Big Bang, many charged particles were produced, electrons and protons and other charged particles were produced. So when cooling started to happen, electrons started to spin, or not spin, revolve around a proton. That is led to creation of hydrogen. So matters were formed after initial explosion. Then eventually what would form? Stars were formed after some time. And after some time, you could see galaxies were formed. So the shape of the galaxies that we draw generally is what is called as a spiral shaped galaxies. So galaxies formed, so stars came into existence, and some matter came into existence. Matter formed, stars formed, then galaxies formed. And then what is happening to distances between the galaxies? Yeah, so this we are saying that the distances between them is increasing. So this distance is increasing. So universe is expanding. If you want to write some basic lines, you can add for Big Bang theory. We won't be writing too much for Big Bang, but some basic line that you can be writing. It is one of the most acceptable theories. It is one of the most acceptable theories regarding origin of universe. One of the most acceptable theories regarding origin of universe. According to this theory, universe came into existence from singularity. Came into existence from singularity. A point object from singularity. A point object having nearly infinite mass, comma, density, and it was very hot. And it was very hot. It started suddenly expanding. It started suddenly expanding, leading to creation of. It started suddenly expanding, leading to creation of space, matter, space, comma, matter, leading to creation of space, comma, matter, energy, and time also. Energy and time also. Next, you can write this part. Uh, the universe is expanding. The universe is expanding at an accelerated rate. The universe is expanding at an accelerated rate. Let's see a few more basic concepts. You all have studied about Newton's law of gravity. And that law says that if there are two objects, let's say m1 and m2, and the distance between them is r, school mein padha hoga, m1 m2 by r square. In simple terms, we say that if the objects are bigger, there will be more force of gravity, and if they are far away, you will feel less gravity. That is the basic idea of Newton's law of gravity. So what is gravity according to Newton? Newton would say it is a force of attraction between any two bodies. So this is a galaxy, massive galaxy. This is also a galaxy. So why are they not coming closer towards each other? There would be gravity acting on them also. So as a Q knew, right, that they are coming closer to each other. Rather, we are seeing it is expanding. So is gravity not acting then at this scale? Nikhil has asked me to dictate a little slow. Okay, I'll do that. So are you all able to copy or able to write? Okay, I'll still do it slow. Yeah. Any answer to this? क्या न्यूटन गलत थे फिर? न्यूटन को किसने गलत प्रूफ किया है? Einstein. We'll see that part also. So gravity does work. It's not that gravity is not acting, but why would still the universe be expanding? Because it means that there is a force which is stronger than gravity and opposite in nature to that of gravity, which is causing the expansion of the universe. What is the name of the force that we have kept? We don't understand it well. So scientists have kept a name for it. That name is dark energy. So the reason for expansion of the universe is dark energy. We'll write about dark energy, but you can just mention scientist scientists say that dark energy is responsible. Scientists say that dark energy is responsible for expansion of universe. Dark energy is responsible for expansion of universe. There are more things we can write, but I don't think it would be relevant. So this much is good enough. Indian mythology में क्या है? Origin of universe. How do you think Indian mythology explains? Shunyavad. That is a philosophy, you know. Created by Lord Brahma. So there was an egg, golden egg, floating in an ocean, and that from that egg, Brahma ji came into existence, and so there is a cycle. So Indian mythology believes in cycle. That this universe is one such cycle. That life or universe is created, it is preserved, and then it is destroyed. So आपने वो पढ़ा होगा ब्रह्मा और विष्णु और फिर महेश. Those things are also true. Very close to this theory itself. Next, we can see composition of universe. What is the universe made up of? So we can draw a pie chart to just understand what are the major components. 5% is what is called as real matter. Next 27% is another matter which is called as dark matter, and the remaining 68% is not matter, rather energy, which is dark energy. When you see real matter, what do we mean by this? So all galaxies, stars, planets, and whatever is there in planets, moons, etc. That would compose real matter. What is real matter? How will you define what is real matter? Physical matter that can be seen. Can we see a black hole? Can we see a black hole? Where will you put black hole as? Real matter, dark matter? Dark matter? Black hole will come under dark matter. So tell me definition of real matter then, if you are saying it has mass and energy, तो इसके पास जो भी मैटर है उसके पास तो मास हो गई, तो डार्क मैटर भी मास है, तो मास में भी एनर्जी होगी. When you say real matter, let's cite the basic definition of real matter. Matter which interacts with light, or we say electromagnetic radiation. Light is one of the electromagnetic radiations. Matter which interacts with electromagnetic radiation. It either emits light, reflects light, or absorbs light. It either emits light, reflects light, or absorbs light. Why can you see me? You can see me because light is falling on me, and then that light is reaching to your eyes. That is why you can see me. Why you cannot see a black hole? Because black hole would be absorbing light. तो फिर कहाँ रखेंगे black hole को? Dark matter. We also wrote absorption. It is interacting with light. Since it is interacting with light, it would be real matter only. So black hole would also be categorized as a real matter only. It is absorbing light. Sun is releasing light, so you can see it. Moon, it is reflecting light, so you can see. Black hole is absorbing light. That is why you cannot see, but it is interacting with light. That is the basic criteria of real matter. But if you sum up all the real matters, what is the percentage that we see in universe? It's only 5%. The next is dark matter. So what do we mean by dark matter? Again, it is with respect to definition of light itself. It will not interact with light. So dark matter, you can write, it does not interact with light or electromagnetic radiation. It does not interact with light or electromagnetic radiation. But what about its existence? How do we come to know then? जब ये दिखता ही नहीं है या interact ही नहीं करता है, how can we come to know that it exists? Gravitational waves can reveal. So you need to first understand gravitational waves, then you can understand dark matter. Dark matter, it is a matter. It is also a matter. So if you talk about matter, it means that it has mass, and anything which has mass would have gravity. And when it has gravity, do you think it will play effect in its surrounding? Yes. So you can mention this part. Dark matter has mass, hence it has. Dark matter has mass, hence it has gravity. Hence it has gravity. You can write this part. Scientists try to calculate. Scientists try to calculate the gravity of particular galaxy. Scientists try to calculate the gravity of a particular galaxy. they found that gravity provided by real matter is not sufficient. Gravity provided by real matter is not sufficient to hold all matter within the galaxy. Is not sufficient to hold all matter within the galaxy. They pointed out that all matter within the galaxy. They pointed out that there exists dark matter. They pointed out that there exists dark matter which provides the necessary gravity. But do you realize this part? Do we know much about black holes itself? We don't know much about black holes itself as of now. And in fact, we don't know much about many of the galaxies and stars and planets. So do you think we would be knowing much about dark matter then? No. So we are very, very blind to dark matter itself. And it is an area, open area in physics where scientists are trying to explore that what could be dark matter, what could be its effect. But we are still not knowing much about dark matter. So it will come out slowly. The ideas and concepts of dark matter will come out slowly. Next, you can write about dark energy then. Dark energy, it constitutes 68% of the universe. It is a force. It is force which is opposite in nature to that of gravity. It is force which is opposite in nature to that of gravity. But much stronger than gravity. It is force which is opposite in nature to that of gravity, but much stronger than gravity. It is this force which is causing. It is this force which is causing accelerated expansion of the universe. Which is causing accelerated expansion of the universe. Below this, you can mention that dark matter and dark energy together, is called as dark universe. Dark matter and dark energy together are called as dark universe, which constitutes 95% of the universe. Dark matter and dark energy together are known as dark universe. Dark universe, which constitutes 95% of the universe. So do you realize that universe is quite vast? अभी तो हम अपने गैलेक्सी में ही एक्सप्लोर नहीं कर पाए and there are billions of galaxies and then we don't know what are there in this dark matter and this dark energy itself. This wheel diagram that you have seen, pie chart diagram, I find it to be true for knowledge also. Something like this you don't need to write, but just for understanding. Let's say this represents what you know. What could be the next 25%? What you know that you don't know. You have the knowledge कि मुझे ये नहीं पता है. So you know that you don't know. What do you think would be this then? You don't know what you don't know. नहीं ऐसा है? And do you think UPSC preparation is going to increase your knowledge horizon itself? So you are knowing something, and it will UPSC journey will try to increase your knowledge. So you are knowing that you don't know something. Let's say you don't know science, but you learn science. But whatever we are learning in class is not sufficient. And in fact, there is something which is much more than what you would be knowing or you don't know. Okay, so this is the knowledge cart itself. Next, we can look at Milky Way galaxy, our galaxy. The shape of our Milky Way galaxy is spiral, but just for understanding, we'll draw it in circular manner. This is the center of galaxy. And our solar system is present here, let's say, solar system. Which was formed roughly 5 billion years ago. So when you study history, you will come across that people first used to think that Earth is at the center of everything and everything is revolving around Earth. That was called as Earth-centric view. Is that view or was that view correct? No. Then came which view? Heliocentric view, that sun is at the center and everything is revolving around it for solar system. Do you think that view is also correct completely? So the question is sun also revolving around something? If sun is revolving around something, what is that something? हाँ, the center of galaxy. तो center में क्या है ऐसा कि उसके around sun घूम रहा है? What do you think is present at center? So scientists have been able to find and tell that at center of every galaxy there exists what are called as supermassive black holes. And for our solar system, for our Milky Way galaxy, the name of the supermassive black hole is Sagittarius A. So this is the name of our supermassive black hole. And almost all the stars in the Milky Way galaxy would then be revolving around it. So our sun is also a star. Our sun is also revolving around the Milky Way galaxy or the center of the Milky Way galaxy. Now, how many times has it circled? That is not very important, but from this time, it has circled 20 times. Why this would be important? Because it is expected that sun will circle 20 more times. After that, it will die. So it has made 20 revolutions till now, and in next or after 20 more revolutions, it is going to die. So the future of sun is not very bright. No? What do you think? What is this distance? This distance, the numerical value is not important, but the unit is, this distance we would write in light years. Can anyone tell me what is light year? Distance traveled by light in 1 year. So why are we using it as a benchmark? Light year को Earth पे क्यों नहीं use करते distance measure करने के लिए? Because it is too large. That would be one logic. And when you say that you are benchmarking distance, we have a meter scale. Should the length of the meter scale change during summer and during winter, or should it remain fixed? It should remain fixed during summer also and during winter also. But do you think speed of light is constant everywhere? What is speed of light that you write? Speed of light roughly we'll say 3 into 10 to the power 8 meters per second. But is this correct? In vacuum, yes. So this would be true in vacuum. When it enters air, it slows down. When it enters water, it slows down. When it enters into diamond, it is the slowest. So speed of light is not same everywhere. Speed of light would change according to the medium. So this value that we write is for vacuum. Okay, so just refreshing for all those who are hearing it for the first time. Light year is a unit of distance. It is the distance traveled by light in 1 year of time. For measuring astronomical distances, so this is an astronomical distance. For measuring astronomical, sorry. For measuring astronomical distances, we can use light years as a benchmark. Why? Because when you say astronomical distances, we say that space is vacuum. And since it is vacuum, light would be moving at constant speed. So because it is moving at constant speed, you can use it as a reference or as a benchmark also. Is this part okay to all of you? Okay. Which is our neighboring galaxy? Andromeda is our neighboring galaxy. Just a small discussion on light itself. This can be a side note, some conceptual aspects, basics. Electromagnetic radiation. Light is one of the electromagnetic radiation. So there are other electromagnetic radiations also. For example, cosmic rays. Then gamma rays. Then comes X-rays. Then comes UV. Then comes visible. Then infrared. After infrared, yes, microwaves. Then radio waves. Then TV waves. All of these are electromagnetic radiations. Again, basic only. We are trying to understand some aspects here, which you will come across often in space topic. So when we talk about light, we mention mostly in terms of the visible light. So why there is an order? Why there is something above? Why there is something below? Is gamma ray faster than normal light? Okay. So this order is written in terms of what is called as frequency. So cosmic rays have the highest frequency, and then comes gamma rays, then X-rays, then UV visible. So in this way, this is the order of frequency. Now, when you say frequency is higher, this side, you need to understand this part. C is equal to lambda into frequency. C is given as speed of any wave, speed of wave. In this case, we are talking about electromagnetic radiation. So you should understand, gamma ray are not traveling faster than visible light. All of them are moving at same speed. All of them are moving at speed of light itself. So all have the same speed. Then what is difference? The difference lies in frequency and wavelength. So if cosmic rays are having very high frequency, frequency ज़्यादा है, तो क्या कम होना पड़ेगा? Wavelength. So this side frequency is higher, but wavelength would be lesser. This side wavelength would be higher. So all these electromagnetic radiations, they have different frequencies and different wavelengths. The mobile phones that we are using, it is also using electromagnetic radiation. Which radiation does it use? It uses radio waves. So your 1G phones, 2G, 3G, 4G, to a certain extent 5G, and some part of 5G also lies in microwaves. So it is using electromagnetic radiations only for transmitting information. Why do we say 5G is faster than 4G? 5G phone faster माने जाते हैं than compared to 4G. Transmission speed is higher. Frequency, you can understand something like sending and receiving. So if frequency is higher, you can send and receive faster. So data packets can be sent and received faster. So when frequency is higher, the internet speed would be higher. But when speed is higher, range would get slower. So 5G का speed ज़्यादा होता है, but उसका जो coverage area है, it would be lesser. So you will have to install more towers for the 5G network itself. Are you getting this part? You will come across telescopes. You will come across names like James Webb Telescope. James Webb Telescope would try to capture which light? It doesn't capture this light. It captures infrared light. Okay, we'll try to see that in later part, but you should have an understanding of this, that all of them are having same speed, but frequency is different. And do try to remember this order also, because many questions are framed on this understanding itself. And you would also realize that some of these waves would be harmful for human body and living organisms. Which one do you think would be harmful for living body? Higher frequency. So something from here and above would be harmful for our body, because when they cross through our body, they can rattle our DNA and they can break the DNA also or cause mutations in DNA. That is why they would be harmful for our body. High frequency waves would be harmful for our body. Coming to next then. Okay, let's now see solar system. I know you might have studied this already, but we'll relook at it and we'll look at the different structural part first. First, we'll look at the structure. So let's say here is sun. What is the outermost part of solar system called as? Pardon? Oort cloud. Yeah, good. So the outermost part is called as Oort cloud. We'll try to see that what is the idea of Oort cloud itself. Then what comes next? Not or below this. Kuiper belt. Something beyond Kuiper belt also exists. What is this boundary? Heliosphere, or yes, we will call this as heliopause. The boundary of the heliosphere, that we would say. Then comes what you mentioned would be the Kuiper belt. So let's say this is the Kuiper belt. Then just to mark out the planets, I'm just writing the initials: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. What can I draw for Kuiper belt? Pluto. There are other objects also that we can mark. In between Mars and Jupiter, there exists, yes, asteroid belt. So you'll find asteroids mostly in the asteroid belt, but you can find elsewhere also. That we'll see. So this is the asteroid belt. This is the broad structure. Okay, let's write something about Oort cloud. What can we say regarding Oort cloud? What is this boundary? Interstellar boundary. यहाँ इसके beyond क्या नहीं हम experience कर सकते? Gravity of sun. So you can simply write what is Oort cloud. Oort cloud, it is the boundary of sun's gravity. It is the boundary of sun's gravity. Oort cloud is the boundary of sun's gravity. What can we say regarding heliopause? Heliopause. To understand heliopause, you need to understand this part. Sun is producing charged particles. Sun releases light, but along with light, it also produces charged particles like electrons and protons, and it pushes the electrons and protons into the solar system. So sun is releasing not only light, but electrons and protons into solar system. These electrons and protons or charged particles can travel to a certain distance only. That distance or that boundary would be called as the heliopause. So sun is releasing, you can just mark this in this way. So sun is releasing these charged particles and it cannot go beyond this. So you can write what is the heliopause. It is the boundary of the charged particles. It is the boundary of the charged particles released by sun. It is the boundary of the charged particles released by sun. Now you would be aware of this fact. In a wire, when electrons flow, what do these flowing electrons produce around themselves? Magnetic field. So flowing charged particles, they produce magnetic field around themselves. So it creates magnetic field. So these are flowing charged particles or flowing electrons. So do you realize this, that when sun is releasing those charged particles, it is traveling in space and it is going till heliopause. Those charged particles which are flowing, they would also be creating magnetic field. So it creates magnetic field for the sun. That is called as the magnetosphere. So can we then say that heliopause is also the boundary of sun's magnetic influence? Okay, so you can write the context that flowing charged particles produces magnetic field around itself. Flowing charged particles produces magnetic field around itself. Hence heliopause is also boundary of sun's magnetic influence. It is also the boundary of sun's magnetic influence. Then you can write about Kuiper belt. Kuiper belt, it is a donut shaped region. Kuiper belt is a donut shaped region beyond Neptune, beyond the planet Neptune. Donut shaped region beyond the planet Neptune. Pluto and other dwarf planets. Pluto and other dwarf planets are present here. Pluto and other dwarf planets are present here. Kuiper belt is also source of present here. Kuiper belt is also source of comets. We will see that in some detail later, but it is also source of comet. One mission was sent by NASA for Kuiper belt. You can mention this. New Horizon mission of NASA. New Horizon mission of NASA was sent to Kuiper belt. New Horizon mission of NASA was sent to Kuiper belt to study Pluto and its moons and more. To study Pluto and its moons and more. So I will keep giving you small homeworks in the class that you have to find for yourself. So do find about New Horizon missions a little more. So find out, it found out a body which is called as Aerocoth. What is Aerocoth? What is this? So this is a homework for you. Have you heard the name of Voyager 1 and 2? Voyager 1 and 2. Voyager, this mission was sent by NASA way back in 1960s, 1967, or 1960s or 1970s, or 70s only, I guess. So Voyager has been the most distant object ever sent by humans. It has crossed heliopause also. So as of now, Voyager 1 and 2 are here. So V1 and V2. You can just mark it out so that you have it in your memory, that Voyager 1 and 2 are the most distant objects ever sent by humans. So no other spacecraft has gone so deep into space. That is Voyager 1 and 2. If you have interest, you can read about Voyager 1 and 2, who was the scientist who planned this one and why it was sent in that period only. So you can read about that. But it is one of the feats of NASA and humanity, you can say. Next, let's begin from this side then, Sun. So we'll try to understand Sun. So Sun is a star, and it was born roughly 5 billion years ago. We say that it is in this phase now. That is, it is a main sequence star. So when you say main sequence star, we should be understanding what do we mean by it is in a main sequence. We should understand then birth of a star. The birth of a star, the famous thesis or hypothesis is which? Yeah, nebula hypothesis. So stars are born from nebula. What is nebula? Okay, clouds of dust and gases. So it would say that stars would be born from clouds of dust and gases. So this we can say it is cloud of gases and dust, and we are imagining that it is mostly gas. So what is going to happen? Some particle will act as a nucleus and it will attract the neighboring particles due to gravity, and it will keep on growing. So the nucleus here would keep on growing, or it will become bigger and bigger. It would be attracting other neighboring gaseous particles and other particles also. So what is happening here? Gravitational compaction will take place. So from nebula, we would get to this stage that gravity would be forcing things to form a ball of gases and dust. Now, when gravity is compressing things, do you think it would increase the friction between the atoms and molecules? So the friction between atoms and molecules will increase. Will the temperature then increase between them? So this will lead to increase in temperature. It would reach to a stage where it becomes quite big enough. So this stage we call it as, it has not become a star even now. We will call it as protostar. But the temperature here has increased to a very great level. And after this, what is going to happen? Fusion, because the temperature has increased to such an extent that fusion of hydrogen into helium would begin and stabilizes. We'll see fusion, but the idea is now the temperature has crossed a threshold that now hydrogen can be fused together. So 4 hydrogen atoms would be fused together to form a helium. We'll see that. So just remember, hydrogen is fusing to produce helium, and that is the source of energy for our sun or for most of the star. Then we would start calling it as the main sequence star. So it would then start to release heat or energy and light. Protostar. This is not prostar, this is protostar, a stage just before the main sequence star. So here light and energy is released, and this is called as the main sequence. So our sun is at this stage, that is, it is in main sequence. So it is producing heat and light, and it is also not only producing the visible light, but it is also producing other radiations also. Now here we said fusion of hydrogen begins, and it stabilizes. What if it has not stabilized? So when young stars are born, it might be the case that the fusion has not stabilized. So if it has not stabilized, we call that star as Cephids. So you can write this below this one, that what are Cephids? Cephids, these are young stars. Cephids are young stars where fusion has not stabilized. These are young stars where fusion has not stabilized. So it brightens and dims. So it brightens and dims periodically. It brightens and dims periodically. Scientists consider them as torches. Scientists consider them as torch or torches to study space or universe. आपके लिए दूसरा छोटा होमवर्क है, find out then what do you mean by brown star. What do we mean by brown star? Let's see that something in more detail here. Fusion of hydrogen. So the next subtopic would be for sun. What powers sun? Nikhil, are you able to now write? Is this lecture available on YouTube? I'm not aware that whether it is available on YouTube or not. अभी तो recording ही हो रही है. What powers sun? So here we are basically trying to understand fusion process. Fusion is important. We'll deal with that in more detail in nuclear topic also, but here you should have some basic idea. What do we mean by the term fusion? Literally it means combining or joining. So what are we going to combine here? We are going to combine small atoms and we are going to combine hydrogens to create helium. For this, you should have some basic idea regarding atomic number and mass number. This number that we write, that is at below or that is at bottom, this number is called as, this number is atomic number. What about this number? This number is called as mass number. What is atomic number? Yes, so this is the important idea that you should remember. Atomic number is number of proton. Number of proton is unique for an element. ऐसा नहीं हो सकता है कि आपने किसी element को लिखा और उसमें ऐसे let's say I take X and I write 6 and I can say that it is nitrogen. It is carbon only. It means that atomic number is identity card of an element. It is unique for every element. So no two elements can have the same atomic number. So it is based on the number of proton. This number that you see, mass number is sum of proton plus neutron, basically what is there inside the nucleus. So mass number is sum of proton and neutron. Carbon, you would be aware, it has a 6 atomic number and the normal mass number is 12. But it can also have a mass number of 14. Nitrogen can also have a mass number of, or it has the normal mass of 14. So two elements can have same mass number, but they cannot have same atomic number. Atomic number would be unique. Now here what we are trying to understand, we are saying what powers the sun, it is fusion of hydrogen. अच्छा कुछ बेसिक्स लिख लेते हैं, उसके बाद फिर एक्सप्लेनेशन पे देखते हैं. Let's write some basic here. What powers the sun? You can write fusion of hydrogen into helium. Fusion of hydrogen into helium is the source of energy of sun. For fusion to occur, plasma state is required. For fusion to occur, plasma state is required. What do you know about plasma? Semi-solid, semi-liquid, we would say superheated matter. So you can write super, what is plasma? You can write superheated matter. So plasma is superheated matter. At this state, gases become ionized. Gases becomes ionized. For example, if you superheat hydrogen, or you take it to million degrees Fahrenheit, then it will split into hydrogen and protons and electrons. This charge particle at high temperature is your plasma. तो आपको प्लाज्मा समझना है तो मतलब बस यही है. It is charged particles. So when you superheat, electrons which are revolving around hydrogen will get ripped off, and so electrons would be present separately and protons would be present separately, and they are revolving or moving around a particular place, and they are at very, very high temperature. That is what is called as plasma. So you need this state for fusion to happen. This is called as fourth state of matter. The first three states of matter are solid, liquid, and gas. So this is called as fourth state of matter. Plasma is fourth state of matter. आपके NCERT में fifth state of matter we mentioned है. So if you're interested, you can go and study fourth state of matter. Now, when we go for fourth state, what is going to happen? You should also understand this, that fusion of 4 hydrogen atoms would create or helium. Helium का mass number 4 होता है. So you actually need to fuse 4 hydrogens to get helium. So when we try to fuse hydrogens, what is the problem that we are going to face? Let's say this is the hydrogen that we are trying to fuse. These hydrogens we want to fuse. We are saying that we can fuse them together. So we have to bring these 4 atoms very close to each other, and then eventually it will fuse to form helium. But when we try to bring them very close to each other, what is the problem that we are going to face? Do you realize that these are electrons? When these electron clouds come close to each other, will they repel each other? Because same charge particles repel. So what we are going to do, we are going to get rid of the electrons. तो चलो electrons तो rid हो गए. We now are having 4 protons. When we create plasma, we might get rid of the electrons. Now we are having 4 protons. Now these 4 protons we are trying to fuse. Again, are we seeing the same problem? Electromagnetic repulsion, because these are same charge particles and they will repel. So why do you think fusion will happen? Fusion cannot happen in all part of the sun. Fusion can happen only in core part of sun, where the pressure and temperature is so high that it can overcome these repulsive forces. Pardon? Gravity. Yeah, so it would be basically gravity and the amount of pressure and temperature that it would be creating, because of which fusion will occur. Okay, are you able to get this part? So you can mention this fusion. What is the last line that you wrote? You wrote about plasma, no? Mention this, that fusion of 4 hydrogen atoms would create helium. For fusion to occur, very high pressure and temperature is needed. Very high pressure and temperature is needed, which would be present only in core part of the sun. Which would be present only in the core part of sun. In the core, electromagnetic repulsion between protons. Electromagnetic repulsion between protons could be overcome. Electromagnetic repulsion between protons could be overcome and fusion can occur. and fusion can occur. Let's try to understand this part. So we are saying that fusion of this will lead to creation of helium. Or if I say what is the mass exactly of 4 hydrogen atom, if you look at the mass of 4 hydrogen atom, roughly, it's not very precise, but this is the value. So 4 hydrogen atoms mass would be 4.030 AMU. If I am adding these, then the mass of the helium should also be coming out to be this only. पर ऐसा होता नहीं है. हीलियम का मास जो है वो 4.005 roughly units है. What can you see? Is the left hand mass equal to right hand mass? No. You see that there is loss of mass. That loss of mass is converted into energy, and you might have seen that equation in your physics lab. E is equal to mc square, where m here would be delta m, loss of mass, and c here is speed of light, the value that you wrote before. E here represents energy in joules. Okay, so this you can mention. During fusion there is loss of mass. Which is converted into energy, given by the equation E is equal to mc square. E is energy, m is loss of mass, E is energy in joules. एनर्जी का यूनिट जूल्स होगा, आपको पता होगा ये. m is mass, atomic mass unit ले सकते हैं, and c would be speed of light, the value that you know. You can write one analogy. See, if we know the mass difference, delta m, we know the value of c also. So we can calculate for fusion of 4 hydrogen atom how much energy would be released in joules term. So how much is that energy? So the estimate says that the just fusion of 4 hydrogen atom can power, let's say this tube light, which would hardly be 10 watts, it can power a 60 watt bulb for more than 100 years. Just 4 hydrogen atom. So do you realize the potential of fusion itself? It is considered to be the most efficient energy production process. So you can write this analogy that fusion of just 4 hydrogen atoms, into helium produces enough energy to power a 60 watt bulb, for more than 100 years. To power 60 watt bulb for more than 100 years. Watt क्या होता है? What is watt? Unit of power. So उसके बाद how do we measure it? If I say that this bulb or this tube light is of 60 watt, what do we mean by this? Work done. It is consuming 60 joules per second. That is the idea. So watt means joules per second or per unit time. तो घर के लिए तो आपको वॉट की जरूरत होगी, बट लेट्स से यू आर अ पॉलिसी मेकर, यू शुड नो द नंबर ऑफ द नेशन, दैट हाउ मच इलेक्ट्रिसिटी आर वी प्रोड्यूसिंग, हाउ मच आर वी कंज्यूमिंग, व्हाट इज द इंस्टॉल्ड कैपेसिटी. विल गेट टू दैट पार्ट आल्सो, बट you should be familiar with terms like 1 kilowatt, you should be familiar with terms like 1 megawatt, you should be familiar with terms like 1 gigawatt. Can you tell me what would be 1 kilo? Quite easy. 1000 watt, हाँ, या 10 to the power 3 में चलेगा या सारा. 1 megawatt 10 to the power 6, or I will say 1000 kilowatt would be 1 megawatt. How much would be giga? So this is giga. Yes. So 1000 megawatt would be 1 gigawatt. तो जो पावर प्लांट बनाते हैं, मान लो आपने पावर प्लांट इंस्टॉल करा है, सो इट वुड बी मेजर्ड इन टर्म्स ऑफ मेगावाट. For the country level, we would be using terms like gigawatt. So our country as of now has installed capacity of roughly 460 gigawatt. This is the installed capacity of the country as of now. So when we set up nuclear plants, thermal plants, we would be measuring in terms of megawatt. घर में kilowatt की जरूरत पड़ेगी. So at kilowatt level. So you should just be aware about these terms that we often use in power sector. Fusion, you can also add this one line. We'll deal with this line later. Fusion is considered as future of energy. Fusion is considered as future of energy. We'll try to justify this in nuclear topic. There we'll study fission and we'll try to compare fusion with fission. Then we'll be better placed to answer this. Acha, one more aspect. Sun, the composition of sun, what is it made up of? So sun is mostly made up of hydrogen. So roughly 75% is hydrogen. Then it has helium, which is about 23%, and then some heavy metals, which would be about 2%. Now, do you think these numbers or this composition is same, or is it static, or is it dynamic? It is changing. It is changing every second. What is happening every second? The percentage of hydrogen is decreasing and the percentage of helium is increasing. And can there be a point where this percentage would eventually be 0? Then we would say that sun will, okay, sun will die, or sun dies at this point. You could have asked me, तो helium तो है ना, sun में hydrogen खत्म हो गया, but helium तो है. So why cannot helium fuse and give power to sun? And it is a noble gas. It is stable. So at this temperature and pressure, it's not about nobility. Nobility is mostly with respect to chemistry, that how electrons are located. It's not about electron cloud. It is about nucleus. Pardon? Heavy metals में convert होगा. That can happen, but we'll see. It will not happen for sun. My simple question is, even if hydrogen has got exhausted, why sun will not produce power after that? The source of production of power is what? Fusion. तो fusion तो आप helium का भी कर सकते हो ना? Why the sun is not doing fusion of helium? The simple answer, or you can write this part, sun in main sequence stage. Sun in main sequence stage cannot cause fusion of helium, as it does not have sufficient pressure and temperature. As it does not have sufficient pressure and temperature. Sun in main sequence stage cannot cause fusion of helium, as it does not have sufficient pressure and temperature for fusion of helium. So the answer is simple, कि sun का mass इतना ज़्यादा नहीं है कि वो helium का fusion कर सकता है. So sun is not a very massive star. Sun is actually a small star. So you can write this part. Sun is a small star. It is not a massive star. After this, let's look deeper into the structure of sun, because there are some important concepts there. A structure of sun or layers of sun. So we are just looking at one part. We can cut it out and say that we are looking at this part. This we would call as outer layer. And this we would call as inner layer. In inner layer, we would have the core part. Then we would be having what is called as this is called as a radiative zone. Then this part where you can see something is rising and falling, it is called as convective zone. When we look at sun, we actually see this layer, which is the visible layer. This layer is called as photosphere. Then there is a thin layer, which is magnetic layer. This is called as chromosphere. And the outermost layer is called as this as corona, or this is also called as the crown. These are different layers of sun that we are looking at. We don't need to know all the layers, but some layers we should be knowing. Please, difference between fusion and fusion. I don't know your name because your name is Oppo CPH2643. So 2643 will deal with fusion and fission, specifically nuclear topic. So that is a separate topic in itself. We'll deal there. But here it was just to explain about what powers the sun. Done? Have you heard terms like sunspot? Sunspots. कहाँ होते हैं sunspots? Outermost layer में. Where is or do you think we have been able to go very close to sun and touch sun's corona also? No, we have not been able to touch sun's corona. What do you think? Voyager से heliopause चले गए पर sun के पास नहीं गए. No, no idea. Done with the diagram? Some of you are still drawing. So what is sunspot? Do you think the number of sunspots, is it static or does it change? When does it change? Do you think these questions are important? These questions would be important. Why? Because we'll come to know. Sun, we said, if you remember, it is a dynamic star. So sun is releasing charged particles. It is not only releasing light, but it is also releasing charged particles. But charged particles are not being released like a simple wind. Sometimes sun becomes very, very aggressive and it will throw out huge amounts of charged particle in very short amount of time. So those charged particles will travel through the solar system. It can reach Earth also. And do you think those solar storms can damage Earth itself? You might have come across a news that Starlink project, one of Elon Musk, he has multiple satellites, and some of his satellites were fried by these solar storms which are coming from sun. when we are sending astronauts to space, we might have to track these solar storms also. So what are solar storms? You should understand. And when would it be maximum, when would it be minimum? You should understand this, because it's not only about Earth, it's also about the entire solar system. For everything in solar system, sun is determining all its phenomena. So sun determines what is called as the space weather itself. And sun is the source of energy for the solar system. So you should understand sun and its activity. To understand its activity, you should know some layers of sun also. So let's write first the core. Core. The temperature at the core is multiple million degrees Fahrenheit. Exact number not very important, that is why I'm not mentioning it. Multiple million degrees Fahrenheit. It is the hottest layer of sun. It is the hottest layer of sun. And do you also realize the pressure would be maximum here only at the core? Also, so you can write here, fusion of hydrogen into helium occurs in core. Fusion of hydrogen into helium occurs in core. The heat then moves outwards. The heat then moves outwards. There is a question online, is this a series which will continue till end? End ka to pata nahi. I am not the decider here. So, next, after core, you can mention these two collectively, a radiative zone and convective zone. Radiative zone and convective zone collectively you can write. रेडिएशन कन्वेक्शन आपने स्कूल में सुना होगा या कॉलेज में भी पढ़ा होगा, क्या होता है? Okay, so these are heat transfer mechanisms: conduction, convection, and radiation. Again, basic science. In all these cases, there is heat being transferred from one body to another. Conduction by direct contact. So heat would transfer by direct contact. For example, when you cook tea, so UPSC की तैयारी में बहुत बार चाय बनाओगे आप. So when you touch the kettle, there is a direct contact, and so the heat of the kettle will pass to your hand. That is called as conduction. That would be a direct contact, so it is called as conduction. Convection, जब चाय उबल रहा है, so what is happening to the water at the bottommost layer? It is getting heated up, it is becoming lighter, it is rising up, and then the colder layer above is sinking down. So there is a convection current that is forming when you are cooking tea or anything that you're cooking. Do you see that phenomena happening for air also? Earth, so winds or storms ऐसे ही बनते हैं by convection currents only. Radiation, when heat transfers without the need of medium. So for example, we are receiving sunlight, we are receiving heat from sun, and most of the heat is traveling through vacuum only. So that type of transfer of energy is called as radiation. So coming to this part, this you can write collectively. These layers transfers heat. These layers transfers heat from core to outer layers. Transfers heat from core to outer layer by process of radiation and convection. By process of radiation and convection respectively. By process of radiation and convection respectively. Now, do you also realize this part? Here we are saying this is the hottest. तो आप यहाँ से बाहर जाओगे तो टेम्परेचर प्रोफाइल क्या होगा? What will happen to temperature gradient? Temperature would decrease. So it means that if I follow this logic, the outermost layer should be the coldest layer. Logic तो ये बोलता है, temperature drop होता चला जाएगा हर layer पे layer. So the outermost layer should be the coldest layer. But there is an anomaly. It doesn't happen that way. So the temperature keeps on dropping till photosphere. And after photosphere, temperature again starts to pick up. So the temperature here increases. for outer layers. We don't understand it well. Scientists are trying to find the reason, but this is what is happening in the sun. So you can mention this part, that temperature keeps on falling. Temperature keeps on falling up till photosphere. Up till photosphere. After that, it picks up. After that, it picks up or it rises. After that, it picks up or it rises. Next, we are writing then photosphere. This layer. So when we see sun and when we see the orange or reddish color, we are actually seeing this layer, photosphere. So it appears like surface. But do you think sun has a surface? Sun is mostly gaseous. It doesn't have a surface. But this layer gives an appearance of surface. So you can write this part. It is the visible layer of a sun, which appears orange or red in color. Visible layer of sun which appears orange or red in color. Sun appears to have a surface. Sun appears to have a surface. Sun appears to have a surface. It is the coldest layer of sun. It is the coldest layer of sun. And the temperature here would be about 5005 degrees Fahrenheit. 5500 degrees Fahrenheit. Next, you can also add sunspots. Sunspots are found in photospheres, in photosphere layer. Sunspots are found in photosphere layer. These are the coldest spots on sun. These are coldest spots on sun. Their temperature could be coldest का मतलब ऐसा नहीं कि negative में कुछ भी यहाँ पे. So it is always very, very high. But it is in terms of respect, that from what reference are we talking about. So this is the coldest layer, but you can see that in this layer you might see sunspots which are having lesser temperature than the overall photosphere itself. Why it has a low temperature? This also you can write. Intense magnetic field. Intense magnetic field are found for the sunspots. Intense magnetic fields are found for the sunspots. After this, you can then mention chromosphere. Chromosphere, chromo. Chromosphere, it is a thin layer. It is a thin layer but has very strong magnetic field. Chromosphere, it is a thin layer but it has very strong magnetic field. This layer controls the flow of plasma. This layer controls the flow of plasma. When you see the term plasma, don't get boggled. Plasma simply means protons and electrons at high temperature. That is plasma. It controls the flow of plasma. It is not visible. This layer is not visible by naked eyes. It is not visible by naked eyes. Which point? It is a thin layer. What is the line that we wrote? It is a thin layer. It is a thin layer but has very strong magnetic field. It is a thin layer but it has very strong magnetic field. It controls the flow of plasma. It is not visible by naked eyes. Okay. It can be visible. It can be visible during. It can be visible during solar eclipse. It can be visible during solar eclipses or solar eclipse. The next, you can write corona. Corona, which means crown. It's not the coronavirus. It is the outermost layer of sun. It is the outermost layer of sun. It is the least dense layer of sun. Outermost layer of sun. It is the least dense layer of sun. It is hotter than the previous layers. It is hotter than the previous layers. That is, temperature reaches to few million degrees Fahrenheit. Temperature reaches to few million degrees Fahrenheit. Bracket mention that not hotter than core. Not obviously hotter than core. It is hotter than chromosphere and photosphere, but it is not hotter than core. So its temperature is in million degrees Fahrenheit. Also add this line, this temperature anomaly is an open problem in astronomy. It is an open problem in astronomy. That is, we want to understand why this is happening. It is an open problem in astronomy. We don't have a definite reason for heating of the corona. Also add, it is also not visible. It is also not visible. Can be observed during eclipses, solar eclipses. Can be visible during solar eclipses. It is source of what we call as CMEs, coronal mass ejections. It is source of CMEs, coronal mass ejections. That is, it would throw out huge amounts of plasma from this layer. So that is why we would call it as CMEs, coronal mass ejection. Most of the mass is coming from the corona part, so called as coronal mass ejections. Done? Okay. Now let's see solar activity. Solar activity, or we will try to understand solar cycles. You will come across in geography that Earth is also a magnetic. Earth is also having magnetic field lines. Earth is also having magnetic poles, magnetic north pole and south pole. Are you aware of the fact that Earth's magnetic north pole will flip and it will become south pole and vice versa? But it takes thousands of years for Earth. That is, flipping of the north pole to become south pole and vice versa takes thousands of years for Earth. But for Sun, it takes how many years? 11 years. So for Sun, it takes hardly 11 years. And during that flipping, Sun behaves differently. So there are phases which is called as solar maximum and solar minimum. Okay, so let's cite this part that Sun's magnetic poles flips in every 11 years. It flips in every 11 years. In this phase, the Sun behaves differently. Sun behaves differently. It enters into phases of solar maximum and solar minimum. It enters into phases of solar maximum and solar minimum. During solar max, Sun releases huge amounts of energy. Huge amounts of energy. So the number of solar storms, CMEs, increase. Number of solar storms, coronal mass ejections, that increase. Now, what about sunspots? Will the number of sunspots, will that increase or decrease? Number of sunspots. What are sunspots? Coldest sections of the sun. So the number is dynamic. The number could increase or decrease. So during solar maximum, you can think in this way: sun becomes very aggressive. So it is throwing out huge amounts of particles. So if it is throwing out more particles, then there is some places where there is loss. So will the loss areas increase? So will the number of sunspots then increase? So during solar maximum, the number of sunspots would increase. Okay, so mention this part. During solar max, the number of sunspots would increase. You can write the reason. As sun throws out more particles, there would be more colder sections. As sun throws out more particles, there would be more colder sections. And can we say the reverse would be true for solar minimum? So you can just mention that in solar minimum, a sun becomes less aggressive. During solar minimum, sun becomes less aggressive. So again, as a homework, try to find out which was the recent solar max year. Recent solar max year and the previous solar max year. If you know the recent one, you can get the idea of the past ones also. And do try to check the relevance of the previous solar max with political scenario of India. You will get some correlations also. Now let's understand this fundamental process, which is called as magnetic reconnection. Heard about this idea? You might have heard about auroras. So we are trying to understand auroras here itself. So how does it occur? Why does it occur? That is the explanation given by this concept, magnetic reconnection. Let's cite the definition part, then we'll explain to you. It is a fundamental process, magnetic reconnection. It is a fundamental process in which sun's magnetic field, it is fundamental process in which sun's magnetic field interacts with planet's magnetic field to explosively transfer, interacts with planet's magnetic field to explosively transfer energy and light. To transfer energy and light. It is this, to explosively transfer energy and light. It is this phenomena which is responsible for, causing auroras on planets. It is this phenomena which is responsible for causing auroras on planets. You can also add, for auroras to occur, a planet must have magnetic field It must have magnetic field and और क्या होना चाहिए? Atmosphere and atmosphere. So let's try to see through a diagram itself so that you remember it. If this is sun, so sun is releasing charged particles in the solar system, or earth is also having magnetic field. These would be what are called as the magnetic field lines. This magnetic field creates a shield for us. So this is the magnetic shield of earth. These are magnetic field lines. So what could be happening? Some of the charged particles are able to enter in polar regions, and there they would be creating auroras. This is called as aurora borealis, or it is also called as northern lights. And this one is called as aurora australis, or it is called as southern lights. We'll try to understand this better, but let's first draw it so that you remember it. I try to draw diagrams, however crooked it is, or some meaning could be derived from it. Why? Because you'll forget words, but you'll remember these pictures itself in your mind. And that can be helpful in the exam for recall. So you would be aware photographic memory is stronger than compared to your word memory. Has anyone seen Northern Lights? Yeah, good. Where did you go? हाँ, लद्दाख में देखा है। अच्छा, लद्दाख में क्या इस डायग्राम के हिसाब से लद्दाख में दिखना चाहिए? इस डायग्राम के हिसाब से तो नहीं दिखना चाहिए, पर लद्दाख में क्यों दिखता है? दैट कैन बी अ गुड क्वेश्चन। कैन यू टेल मी व्हाई डू यू थिंक इट? Okay. Auroras could shift, or auroras could be formed at other places also. Yes, that can happen. We'll try to understand that part also. Let's first understand the basic, and then we can understand anomalies also. तो यहाँ पे शंकर जी का फोटो आ गया। इस end has begun. Let's try to understand this part. So what we are saying, Earth is having magnetic field. And do you realize the importance of magnetic field? Do you think this is important for us, for Earth? This magnetic shield, is it important? What do you think is the role of this magnetic shield? It protects Earth. It protects Earth from charged particles coming from sun. So if Earth did not had magnetic field, then charged particles would have blown away our atmosphere, and the existing atmosphere would not be possible, and thus life would not be possible. So magnetic field has very, very important role for Earth. It is protecting Earth from the charged particles coming from sun. So it diverts most of the charged particles, but some charged particles are able to enter in the polar regions. I'm not audible. Hmm. Can you just check someone from the technical guy? So just give a knock there. On YouTube, can guys tell me that am I audible or not? think the mic is okay, but I think some issue with OBS. Hello, check. They have switched on the audio. Just a second. We'll get here. ये ऑफ है ये यहाँ से ऑडियो नहीं ऑनलाइन बच्चे बोल रहे आवाज नहीं आ रही am I audible now online students Sonal am I audible now Mati am I audible which planet do you think has strongest auroras any planet which has strongest aurora which one Earth not Earth obviously not Venus also any other Jupiter Jupiter is the right answer so we'll try to understand that why Jupiter what could be the logic that why Jupiter हाँ बिगेस्ट प्लैनेट है ज़्यादा मैग्नेटिक फील्ड है ज़्यादा थिक लेयर ऑफ एटमॉस्फेयर भी है सो यू नीड टू अंडरस्टैंड दैट पार्ट now I think I would be audible am I audible now online students anyone online can you confirm okay so let's try to understand how auroras are formed what we are saying that the magnetic shield will divert most of the charged particles coming from sun but some charged particles would be able to enter the polar regions when they enter in polar regions do you think earth earth also has atmosphere so these are charged particles which are traveling through our atmospheric gases so when it traverses through hydrogen helium oxygen it interacts with those gases and it makes the electrons to jump and when it makes the electrons to jump it would produce what colored night sky so you might have seen videos you can go home and you can see videos of auroras itself so it produces telecommunication systems it would affect telecommunication systems especially in polar regions it could affect telecommunication systems especially in polar regions another effect would be on what we call as grids. We supply electricity through grid network, and in grids, the wires are open wires. So in wires, electrons flow. Electrons have a tendency to flow on surface of wire. When they flow on surface of wire, do you think these are charged particles which are coming from sun? Do you think the electrons flowing in the wires could also be affected by these charged particles? Yes. So on Earth surface, the grid system, the electrical supply system could also be affected by CMEs or solar storms. So you can add this part. Grid systems on Earth could be disrupted. Grid systems on Earth could be disrupted by major solar storms. Could be disrupted by major solar storms. Do you think they can even ignite and cause forest fires? So they are what? They are charged particles and they can produce spark also. If they produce a spark, can they cause fire? So they can cause forest fire also. So you can add this part. They can cause forest fires in some places on Earth. They can cause forest fires in some places on Earth. But do you think it can cause forest fires across the globe? To sustain fire, you need other conditions also. For example, if a fire occurs even in Amazon basin, every day it rains there. So do you think it will be able to sustain? No, it will not be able to sustain. So it can start a fire, but it cannot sustain. For sustaining, you need other conditions also. UPSC had asked a statement that can these solar storms cause tsunami? Can it cause tsunami? Tsunami पढ़ा है या ज्योग्राफी में अभी आप लोग पढ़ोगे. You will come to know about tsunami. When will tsunami occur? When does tsunami occur? Epicenter should be below oceanic plates. So it occurs due to plate tectonics, and earthquakes should occur in oceanic plates. And not all earthquakes in oceanic plates leads to tsunami. It should be more than 6 on Richter scale. Then only it can cause tsunami. So do you think solar storms can cause plates of Earth to move? No direct evidence. So it cannot cause tsunami. Tsunami is actually caused by plate tectonics, and plate tectonic mechanism or their movement mechanism is different. You'll study that in geography. So there is convectional reason for plate tectonics and not this. So you can add this as a note point here, note point that solar storms. May you please repeat last 5 minutes as we lost the connection? Okay, so what I'll ask the team, to for someone will take the image of the notes and they will send it to the group, so you can copy from there. Will that be okay? Okay. This image, acha, I'll provide you with the image, don't worry. So you will get the notes also. What is the line that you are writing? Note. Solar storms are not directly responsible for causing tsunami. Are not directly responsible for causing tsunami. Sometimes I've seen a statement like this also, that can solar storms affect internet? Have you come across this, that there are optical fibers which are laid in between oceans, or transatlantic fibers are also there? So we are sending light. So optical fibers are carrying light. So data is sent in light form. But the light has to be accelerated at some points. So if electricity is affected, then the acceleration process could be affected. So it is an indirect reason. You cannot say directly it could affect. So there is no direct evidence that it can affect internet services altogether. But sometimes such questions could also be asked. After this, we can move to then planets. You'll study planets in some detail in geography itself, but we'll look at the definitional aspect of planets. For example, you would be aware about Pluto. Pluto is now not called as a planet. From when are we not calling Pluto as planet? 2005, 2006. So from 1930s till 2006, it was considered as planet. Then what happened here, that we are now not calling it as planet, rather as a dwarf planet? It does not have a clear path around. Okay, so it means that it is not meeting a certain criteria. So what are those criteria you should know? So when you say planet must be having some definite criteria, and there would be somebody who would be giving definition of the planet itself. So you can write this one, according to which body? IUC, International Astronomical Union, IAU. A planet must do three things. according to IAU, a planet must do three things. First, what do you think would be the first criteria? Spherical shape is a criteria, not the first one. So first criteria, it must orbit a star. First criteria, it must orbit a star. Bracket for our case, sun. It must orbit a star, bracket sun. Second, it must have enough gravity. It must have enough gravity so that it has shaped itself. So that it has shaped itself into spherical shape. It has shaped itself into spherical shape. Third, it must have cleared its path. It must have cleared its path around sun of similar sized object. Of similar sized objects around its star. Around its orbit. Orbit is around the sun in this case. So we are saying, oh, acha, what is the line that we wrote? Is there a grammatical? It must have cleared its path around sun. Path को orbit बोलेंगे यहाँ पे. It must have cleared its orbit. That also you can write. It must have cleared its path around sun or the star of similar sized objects. And this is the important keyword. It means that it should not have similar sized objects in its path. For example, if you see Jupiter, in Jupiter's orbit, there are asteroids also. But Jupiter would still be called as a planet. But Pluto would not be called as a planet because there are objects which are similar size to that of Pluto. That is why we have chucked Pluto out of this list. So after this, you can just write a concluding line. Pluto fails to meet the third criteria. Pluto fails to meet the third criteria, and also it has highly elliptical orbit. And also it has highly elliptical orbit around sun. एक सीरीज में प्लूटो के बारे में डिस्क्रिप्शन भी है, पंचायत में ना शायद, नॉट सीन पंचायत, क्या है, नॉट रिमेम्बरिंग. So he tries to inspire someone. He says that प्लूटो को क्या फर्क पड़ता है कि आप आज उसको प्लैनेट बोलो या डॉर्फ प्लैनेट बोलो. So who is naming Pluto? Who is giving names to Pluto? We are giving names. We were calling it as planet and we are now calling it as dwarf planet. But has the path of Pluto changed? Has anything changed for Pluto? No. So दूसरे क्या बोल रहे हैं उससे आपको फर्क नहीं पड़ना चाहिए. दैट इज द आइडिया. सो यू शुड बी ऑन योर ओन पाथ. तो अभी आप लोगों ने अपनी जर्नी शुरू करी है, तो अभी ज़्यादा लोग नहीं बोलेंगे, बट कुछ साल जब निकलेंगे तब फिर घर वाले बोलेंगे, फिर रिश्तेदार बोलेंगे, and then you would also say to yourself that probably I'm not good enough. You don't have to say that to yourself. You shouldn't allow others to say that to you. You have to be on your path. So this is a journey, just like Pluto. No, coming back to some other understanding of Pluto, sorry, not Pluto, but this law might be important. Kepler's law of planetary motion. Again, we'll try to understand this in simple manner. Yeah. If it stops rotating, तब वो बचेगा ही नहीं कि उसको प्लैनेट बोल पाओ आप. Why? Because sun is the heaviest object. in the solar system. Sun's mass is nearly 99% of the total mass of the solar system. What will happen if you stop any planet? It will be pulled by sun. It will be sucked in by the sun. So it will have no existence if it stops. So since it will have no existence, then naming it doesn't make a sense, no? So we'll see that part also. So in circular motion, you have to understand certain concepts. Pardon? Yes, by gravity it would be pulled towards the center of the sun. Kepler's law, suna hai? Pada hai? Acha, so the first point, let's write it down, then we'll try to simplify it. It's not so difficult. It is actually very easy. Kepler's law. What he says, first point, the sun is not at center, it is at focus of an ellipse. It is at focus of ellipse while the planet moves in elliptical path around it. While the planet moves in elliptical path around it. What it simply means that you cannot simply say that planets are moving around sun in let's say circular path. Rather, they are not in circular, it is elongated circular, or it is moving in elliptical path. So for an ellipse, so this is the shape of an ellipse, you have a center, and you have what is called as foci. So this is one foci. So you have to assume that sun is here and the planet is moving in elliptical path. This is the idea, that planet is not moving in circular path, rather it is moving in elliptical path around sun. Then what is the difference if it is moving in elliptical path? Can you see that the distance between the planet and sun will not be same around the path? So sometimes it will be quite far away from sun, sometimes it will be close to sun also. What is this distance, the maximum distance between sun and planet, called as? Okay, so this is called as epihelion. So when you see the term helion or helios, it means sun. So the point which is away, for your memory, something which is away is epihelion. These, the shortest distance would be called as, so this distance is called as perihelion. This is his first law. He's simply saying that planets are not moving in perfect circular paths, rather they are moving in elliptical path. You have to assume that sun is at one of the focus and planets are moving in around them in elliptical path. The distances between the planet and sun keeps on changing. Now, second law. Let's first try to see second law or understand second law itself. Do you think speed of the planet at this point, let me mark this as v aphelion and v velocity at perihelion and velocity at aphelion. What is the case? Is VA equal to VP, or VA is more than VP, or velocity at A is less than that of? I'm asking, is the planet faster here or it is faster here? कहाँ पे स्लो होगा? पास में स्लो होगा, पास में फास्ट होगा, as your friend asked very recently. Let's think in this way. When we are close to sun, is the gravity on the planet more? Thus, planet is here, so distance is less, so gravity felt by planet is more. If I stop the planet at this point, what will happen? Sun will absorb it. It has to escape the gravity of Earth. And since gravity is higher here, so it should move faster at this point than compared to this point. Are you getting this? So what we are saying, what is the second law? Second law is in mathematical terms, but in simple terms, it simply means speed of the planet around sun is not same. It varies. It is different. It is faster here and it is slower here. That is the second law that you can mention. So you can mention that second law. Speed of the planet around sun. Speed of the planet around sun is not constant. Speed of the planet around sun is not constant. It varies. Is not constant or it varies. It is fastest at, you have to fill in the blanks. It is fastest at perihelion. It is fastest at perihelion. You can write a simple region, put a dash and write, since it is closest to sun, since it is closest to sun, gravity is more, comma, it should move faster to escape. It should move faster to escape gravity of sun. It should move faster to escape gravity of sun. He gave 3 laws. The third law is more in mathematical terms, but we'll try to simply understand this. You can write this one and then we'll go for a simple understanding of this. T square is proportional to R cube. Not P, T, time. यहाँ time period of revolution है. Okay, so people, those who are sitting very close, T here is time period of revolution. And R here, क्या R एक फिक्स्ड डिस्टेंस है, एलिप्टिकल पाथ है, तो एक R तो है नहीं, तो क्या लेना पड़ेगा, एवरेज डिस्टेंस. So this one is called as average distance between sun and planet. Average distance between sun and planet. What does this mean? It simply means, or in simple terms we can say, as you move away from sun, it will take longer time for revolving around sun. As simple as that. What is the time period of revolution of Earth? Time period for Earth is 365 days. Is it exact? Then क्या ऐड करना चाहिए? 1/4 of a day. हर 4 साल में फिर इसको accommodate करते हैं and then we have a leap year. So the time period of revolution of Earth is 365, 1/4 of a day. So for planets like Mercury and Venus, will it be more than this? Can it be more than this? It will be, for Mercury and Venus, it will be less than this. For planets beyond Earth, like Mars, Jupiter, Saturn, Uranus, it will be much more than this. That is the simple idea. But do remember this idea that as you move away from Earth, from Earth also, or from Sun, the time period of revolution would increase. Let's also see the direction of movement or revolution and rotation of planets. So some terms you should be familiar with. Planets are revolving around sun. It is a typical, you can say, circular motion. So in circular motion, how do we know the direction, or what do we call those directions as? So either we use the term anti-clockwise or clockwise direction. So we use terms like, for solar system, prograde direction. What do you think is prograde for solar system? And then we use the term retrograde. Which direction is prograde for solar system? Anti-clockwise. So anti-clockwise is prograde direction. Oh, sorry, I've drawn clockwise. I've written anti-clockwise. Or we can also say west to East. So obviously retrograde would be then clockwise or east to west. So you have to tell me what is the direction of revolution of all planets? Of all 8 planets. Are they moving in same direction, opposite direction, or few are moving in some direction, few in other direction? Or is there any singularity in this aspect also? Okay. Revolution means around sun. Rotation would mean on their own axis. So I'm asking a revolution. What is the direction of revolution? Yes. So you can write this part. All 8 planets are moving around sun in prograde direction. All 8 planets are revolving around sun in prograde direction. What about rotation of the planets? It is different. So what can you say? So next you can write rotation of planets. Rotation of planets, hyphen. Most of the planets are spinning on their axis. Most of the planets are spinning on their axis in prograde direction. Most of the planets are spinning on their axis in prograde direction, except Venus and Uranus. Except Venus and Uranus. Why do you think that is the case कि सारे एक ही डायरेक्शन में घूम रहे हैं? ऐसा कोई कॉन्स्पिरेसी हुआ है, नेचर ने करा है या गॉड ने करा है? So is there some game plan by nature that is all moving in one direction? And what do you think is the plane of movement of all planets? So let's say if this is sun, Earth is moving in a particular plane. So what about plane of Mercury? Is it, let's say, moving like this, or Jupiter moving like this? They are all moving nearly in the same plane, whatever is the plane of Earth. So you can add this part also. Uh, all 8 planets are moving. All 8 planets are revolving nearly in the same plane. Are revolving in the same plane, that is Earth's plane. That is Earth's plane. Just again a small discussion for this part. This I think you will cover more in detail in geography, but just to make you aware, if this is sun and this is Earth, tell me the date here and tell me the date here. Date for ephelion. Uh, 22nd December होता है, 21st June होता है. These are solstices, so winter solstice and summer solstice. So I'm asking you, where should I write which date? December here, and March वो equinox होता है, वो इधर और इधर आएगा. I'm asking you June and December date. Where? 21st June, which side? So if we are getting intrigued by the fact दूर है, फिर गर्मी क्यों हो रही है? The reason for summer in northern hemisphere is not because of the distance between sun and earth. It is because of tilt. Yes. तो अर्थ का जो टिल्ट है वो इस तरफ है. So it has a tilt of this, this angle is 23 and a half degree. So it is tilting. So the northern hemisphere gets straight sunlight. So it gets heated up. So we experience summer in northern hemisphere here when we are away from sun. Getting this part? तो क्योंकि ये tilt ऐसा है तो अब ये वाला part जो है वो sun की तरफ ज़्यादा है. So Australia would be receiving sunlight, or summer in when we are experiencing winters. Okay, so this is so tilt is important. So tilt you have to study. Tilt is the reason which causes seasons. So this you should remember. तो tilt ना हो, tilt किसी planet का 0 degree हो या 3 degree हो, तो उसमें season ही नहीं होंगे. You can find out. You can find out for planets that what is the tilt. See, we discussed in general about planets, but what you have to do at home. Again, this is a small homework for you. Read about planets, and NASA's website is a very good source for reading about planets. And you should read in what respect, what are the things that you have to study for planets. So read about the composition, some composition of, or what it is made up of. Read about the atmosphere. So what is the atmosphere made up of? What is the role of the atmosphere there? Then you can read about surface of it. You can read about magnetic field of this. If you're interested, you can add more like density, ring system. Ring system सब में नहीं होता है, but the ones which are having you should know, and something about moons. So in this framework, try to read different planets. It would be better that you copy or make some notes on the different planets itself. For example, if I ask you about Mars, what can you say regarding Mars to me? ये सब स्कूल में पढ़ा है. It is the smallest planet. Is it the hottest planet because it is the closest one? So why it is not hottest? That type of question you should be knowing. वहाँ पे atmosphere नहीं है, बहुत कम atmosphere है. So even though it is very close to sun, it receives a lot of sunlight, but it radiates all the heat that it is receiving, so it is not getting heated up. So for a planet to become hotter, it should have atmosphere, and only atmosphere will not make it hotter. The composition of the atmosphere is important. So Venus has thick layers of carbon dioxide and vapors of sulfuric acid, which are greenhouse gases. So it traps the heat coming from sun. That is why it becomes hotter. Is Venus our neighbor? Venus is our neighbor. Venus is known as twin sister of Earth. It is similar size to that of Earth, but it is very, very hostile. Why it is very, very hostile? Because of thick layers of CO2 and sulfuric acid. Temperature is very, very high. The temperature can go up to as high as 450, 470, near to 500 degrees Celsius during the daytime. And during the night time, it could go to minus 170, 180 degrees Celsius. It's not only about the temperature range, it is also about the pressure. On surface of Earth, we experience 1 atmospheric pressure. The air column exerts 1 atmospheric pressure. That is the benchmark that we have. On Venus, we would be experiencing 90 atmospheric pressure. So do you think anything can survive at such intense pressure and temperature? No. तो नासा भी हिम्मत नहीं करता है कि वहाँ पे स्पेसक्राफ्ट्स या किसी लैंडर को भेजे. Russia tried and it melted. It melted within the hour itself. So Venus is very, very hostile. Despite it is our neighbor, it is very hostile. So life, it cannot support life. So you should always think of the planet in terms that whether it can support life or not. Now we have an interest in Mars. Why we have interest in Mars? Because Mars is not so hostile. Mars is barren, but it is expected that we can change its climate and we can bring in certain atmosphere which is favorable to humans. So we can go to Mars. You would have seen that we are sending missions to Mars. NASA has sent a lot of missions to Mars. Elon Musk says that Mars is our insurance. He says that humans should not be living only on one planet. If dinosaurs can get killed by asteroid 65 million years ago, then humans can also get killed. So humans are living only on one planet. That is not a good idea. Humans should be living on Moon and Mars and possibly other planets also. So he is trying that we should be able to go to Mars also. So we have interest in Mars. So you should know about then Mars. Mars is called as red planet. Red क्यों बोलते हैं? Red का significance क्या है? Sulfur dioxide, no, you find Fe2O3, hematite. That is, iron has got oxidized. So if it has oxidized, it means oxygen was there. Yes, so it could hold evidences of life. So from that perspective, you should read. When you go to outer planets, let's say for Jupiter, for outer planets, Jupiter, surface, Uranus, Neptune, they are not solid. They are gaseous planets. They are called as Jovian planets. These terms you can see. They are called as Jovian planets. Life, again, they cannot support life. They do not have a surface. If they do not have a surface, we cannot live there. So it is clear that we cannot live on these outer planets also. But where do you think in these outer planets, which places in these outer planets we can live? On their moons. So they have moons, and their moons can be bigger than some planets also. So you can find out which is the largest moon of the solar system. Do you know which is the largest moon of the solar system? Or किस planet का है? That type of question you should prepare for yourself. Again, factual, something which you would find in very basic books also. So we have some large planets, and those large planets, and the moons of those planets could support life. So try to read about some of those moons. Like you will come across Ganymede, you will come across Europa, you will come across Callisto. So these are some moons, and they are quite big enough, much bigger than one moon is bigger than Mercury itself. So it is big, but it is not called as obviously as a planet because it is circling around Jupiter. You will see that all outer planets, they have ring system. So in diagrams or images that we see of solar system, we generally see ring system of Saturn. But all outer planets have ring system. All outer planets have moons. Inner planets, all of them do not have moons. Earth is having moon, Mars is having moons, but try to find out for Mercury and Venus. So in this respect, you should try to read the different planets. Again, few factual things, few interesting things about the different planets. For example, you saw for Uranus that its spin is opposite. It is moving in retrograde direction. And in fact, we say that it appears to be rolling on its orbit around Sun. So those type of information you can get from NASA's website, and you can note it down. If possible, try to note down some missions also, which NASA and other agencies have sent to these planets. We'll be studying those missions, but you can read beforehand itself. Done? After planets, we can discuss small body systems. That is asteroids, meteors, and comets. Asteroids, meteors, and comets. Why they are called as small body system? They are called as small body system because if you sum up the masses of all of these bodies, it will not be more than the mass of our moon. But they are highly scattered in solar system. That is why they are called as small body system. If they are small, why they are significant? Why are we still studying them? The reason we are studying them is because they do not change, or they haven't changed since their formation. They were also formed 5 billion years ago. And since their formation, they haven't changed. If you look at planet, do you think Earth is same as was the case when it was formed? No. Initial atmosphere of Earth was blown away by sun, then it developed its own atmosphere, so life has come on Earth, so it has evolved. All planets, all moons, they evolve, but they do not evolve. They haven't evolved. If they haven't changed, they are like fossils. They are like fossils of the solar system. So that is why there is a lot of interest in studying asteroids, meteors, and comets. So one line at least we can write, then we can close also. Small body system, their collective mass would not be more than their collective mass would not be more than the mass of our moon. Would not be more than mass of our moon. However, they are highly scattered. However, they are highly scattered in the solar system. They haven't changed. Next point. They haven't changed since their formation. They haven't changed since their formation. While planets, stars, moons, while stars, planets, moons, have evolved. Hence, they have evolved. Hence, they are like fossils of the solar system. Hence, they are like fossils of the solar system. We can then study separately asteroids. You can stop writing, you can just hear me out. Tomorrow we'll write this part. What do you know about asteroids? क्या होते हैं asteroids? They are rock particles in space. Do they have atmosphere? They do not have atmosphere. So we use the term failed planets. They were capable to become a planet, but they did not become a planet. So they have become what are called as asteroids. So they are space rocks and they do not have atmosphere. What are they orbiting? They are orbiting sun only. And do you think they can enter Earth's atmosphere? Yes, they can enter Earth's atmosphere. In past, the incidences, dinosaurs got killed by asteroid only. In recent times also, some asteroids have fallen on Earth and they cause major devastation. So there is a fear that asteroids can attack Earth in future also and can cause major devastation. We are interested a lot in asteroids. You will come across, we'll see the names of few missions. NASA studied an asteroid called as Bennu. We'll see that. It studied an asteroid called as Bennu. It collected sample from Bennu and it dropped the sample in Utah Desert of USA. They studied the sample and in the sample they found the sample is containing amino acids. Aware about amino acids? For now, just remember amino acids are building blocks of protein. Protein is building block of life itself. It means asteroids are containing biomolecules which could lead to production of life. On Earth, there is a conception that life started on Earth 3.8 billion years ago and life began as bacteria on Earth. But there is no settlement that whether life started within Earth, from within inside the Earth, or it came from outside asteroid also. So asteroids could be containing some life materials itself. That is why there is a lot of interest. We are collecting more and more samples. So Japan has collected, USA has collected, China is also collecting. So we are seeing that kind of interest with respect to asteroid. So from astronomy perspective, a biology perspective, there is an interest for asteroid, but we are also trying to protect Earth from asteroid attack also. So we'll see that what are we doing to protect Earth from asteroid attack also. I think we'll close here for today. If you have any doubt, you can ask. Online students or YouTube students, if you have any doubt, you can ask. Anyone has made, so most of you are making notes. Someone who thinks has a good handwriting, you take an image and just send some images. Mati, from which part have you missed actually? Magnetic reconnection. So you can take a photo, 3-4 pages of magnetic reconnection and you can send it to the group. I'll ask the team to send it to you. So from magnetic reconnection onwards. Okay, okay. I'll ask someone to send it. Okay, we'll see you then tomorrow.